Today we will go with the classes saturated hydrocarbons. The hydrocarbon term itself, hydro means hydrogen and carbon. So it is consists of hydrogen and carbon atoms. So why they are called saturated hydrocarbons? Because we know that the carbon atomic number is 6 and having the valency 4. So all the 4 valencies are satisfied by a single covalent bond either with the carbon and with the hydrogen atom. Let us take methane. So it is a single bond with hydrogen. And if you take ethane, here also there is a single bond with carbon. Also, number 2 point, since they goes with substitution reaction takes place, means they are very less reactive. Why they are less reactive? Because in the single covalent bond, there is a non-availability of electrons in this. And they are also called paraffins. Paraffins means having little affinity. So, they are called paraffins because they are unreactive under ordinary conditions. So these reasons you must be knowing. Here it is alkane and the general formula is CnH2n plus 2. If you put n is equals to 1, we get methane. The suffix is ane, so we get methane CH4 and the dot structure we have to do in this way. And if you put n is equals to 2, we get C2H6 which is ethane. So dot structure is this. And the structural formula of methane becomes, you write down in this way, single covalent bond, and here ethane is, we having 2 carbon, so we are going to write down in this way. So this is the structural formula of methane and ethane. One is, we have to go the isomers of butane. Since butane has 4 carbon atoms, so we have 2 isomers. One is normal N-butane and the IPAC name is butane. And another is isobutane. Iso means one methyl group must be attached. So we have the common name isobutane and the IPAC name is, in the second carbon atom methyl is attached, so 2-methyl propane. In pentane we have carbon atoms 5, so we have 3 isomers. Number 1, N-pentane, this is a normal pentane, this way you have to draw it, and the IPAC name is pentane. Next, another one is, common name is isopentane, means one methyl group is attached with the second carbon atom, and the IPAC name is 2-methyl butane. And the third one is, common name is neopentane. Here 2-methyl is attached with the second carbon atom, so we get here neopentane and IPAC name is, then since there are 2 methyl, 1, 2-dimethyl propane. In laboratory, methane and ethane can be prepared. Both the process more or less is same. So in laboratory, when methane is prepared, we are taking sodium acetate, that is CH3COONA, with soda lime we are using here in presence of calcium oxide. So we are getting sodium carbonate plus methane. See here this portion is getting eliminated and this portion is getting eliminated, and we are getting CH3 and one more H, that is CH4 we are getting, and rest 2 sodium and CO3, that is Na2CO3 we are getting here. In the same manner, when we have to get the preparation for ethane, then we are taking C2H5COONA, that is sodium proponate we are using here in presence of soda lime. Here also this portion is being eliminated, and we are getting C2H5 and one more H, we are getting C2H6. Now when in both the cases, the gases which is evolved, it is slightly soluble in water and it is lighter than air. So it is collected by downward displacement of water. Downward displacement of water. You have to know these things before your ICSE examination. Now other methods of preparation of methane and ethane. So methane and ethane can also be prepared by using methyl iodide, which is reduced by nascent hydrogen. So how do we get nascent hydrogen? We can get nascent hydrogen by the action of zinc over HCl. Then we get here nascent hydrogen. So methyl iodide is reduced with the nitrogen to get methane, and similarly bromoethane is also reduced to get here ethane. So these are the other methods we can get methane and ethane by reducing with the nascent hydrogen. One more thing is that when water is added at room temperature to aluminum carbide, that means Al4 carbide C3 with 12H2O gives 3CH4 plus 4 ALOH thrice. So this we have to equate it another. So this is one more method how we can prepare methane in other than the laboratory method. Let's go with the chemical properties of methane and ethane. Since methane and ethane are saturated hydrocarbon, so they do not react with base like sodium hydroxide. They do not react with oxidizing agent as well, and also they do not react with reducing agent. So they do not react with base, and also they do not react with oxidizing agent like potassium permanganate and reducing agent like sodium metal. They do undergo the substitution reaction and also fully combustion reaction, and the reactions are: during combustion methane reacts, so it forms carbon dioxide and water with a large amount of heat energy is released. In the same way, ethane also, it produces large amount of heat energy is released. Due to low content of carbon, they get fully oxidized, and hence no sooty flame is formed during this reaction. Alkanes undergo substitution reaction. So all alkanes react with chlorine, bromine, iodine. So first, for instance, let us take an example of methane when reacts with chlorine under diffused sunlight or 600 Kelvin, then we get methyl chloride. This can be further, here chlorine means we can write in this way, instead of this we can write in this way, then hydrogen is substituted with chlorine, so we get CH3Cl and HCl. In the same way, the product which we have got CH3Cl, again with chlorine, it produces CH2Cl2 plus HCl. Again CH2Cl2 plus Cl2. Again one more hydrogen is being replaced, substituted. It becomes CH3. It becomes CHCl3 plus HCl. Again CHCl3 plus Cl2 gives CCl4 plus HCl. So methane and ethane have more further uses. Methane are used in the preparation of methanol, methanol, etc. In the same case, ethane is used in the preparation of ethanol, ethanol, and ethane, etc. Further, methane can be used as a domestic fuel. Even ethane can also be used as domestic fuel. And also, it forms ethyl chloride, which is further used to make tetraethyl lead and used in dry cleaning.